Matrix operations. In this lesson, we want to talk about performing arithmetic operations with matrices, and then in the next lesson, we'll talk about finding the inverse of a matrix. And here's your checklist, and that is to try the following: adding and subtracting matrices, multiplying a matrix by a scalar, and then to try multiplying two matrices. Now, you can only add or subtract two matrices if they have the same dimensions. So for example, we have A, which is the matrix 1, 0, 3, 0, 2, 4, and B, which is the matrix 2, 1, 2, 3, 2, 2. And notice that A and B have the same dimensions, so we can add them up in this case. So let's try A plus B. So we say 1 plus 2 is 3. 0 plus 3 is again 3. 0 plus 1 is 1. 2 plus 2 is 4. And 3 plus 2 is 5. And 4 plus 2 is 6. Notice that we added the corresponding elements from each section in the matrix, and that's how we were able to get A plus B. And let's repeat this process for A minus B. So we have 1 minus 2. It's negative 1. 0 minus 3 is negative 3. 0 minus 1 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. And 4 minus 2 is 2. Now you can multiply any matrix by a scalar. So here we have the matrix A, which is 1, 0, 2, 1, 1, 1. And we are multiplying it by the scalar 2. And when you're multiplying a matrix by a scalar, you want to multiply each individual number in the matrix by that scalar. So we have 2 by 1 is 2. And then 2 by 2 is 4. And then 2 by 1 again is 2. 2 by 0 is 0. 2 by 1 is 2 again, and 2 by 1 is 2. Now, matrix multiplication is a little bit more tricky. You can only multiply two matrices if the number of columns in the first matrix is the same as the number of rows in the second matrix. Confusing, right? I know. So let's look at the setup for a matrix multiplication. We have a matrix A with m rows and n columns. And we have a matrix B with n rows and p columns. Notice that we just need the middle numbers to be the same in order to do a matrix multiplication. Furthermore, the matrix that we end up with is going to have m rows and p columns. Let's see this in action. So here we have a matrix A, which is a 2 by 3 matrix, and then we have a matrix B, which is 3 by 2. So since the middle numbers are both 3, we know that matrix multiplication is legal in this case, and we end up with a 2 by 2 matrix in the end. Now to perform a matrix multiplication, we go row by column. So to get C11, we multiply the numbers in the first row of A by the numbers in the first column in B, and then add those up. So we have 1 by 3 plus 2 by 2 plus 1 by 1. And this gives us 8. Now to get C12, we multiply the first row of A by the second column of B. So we get 1 by 1 plus 2 by 1 plus 1 by 1. And this gives us 4. Now to get C21, we need the second row of A times the first column of B. So we get 0 times 3 plus 1 times 2 plus 3 times 1. And that gives us 5. Now, to get C22, we need the second row of A and the second column of B. So we get 0, 1, 1 by 1, and 3 by 1. And that gives us 4. Let's see one more example. This time we have A being 2, 1, and B being 3, 1. A in this case is a 2 by 1 matrix, and B in this case is a 1 by 2 matrix. Notice that the middle numbers are the same, and we once again end up with a 2 by 2 matrix. So C11 in this case will be 2 by 3. C12 in this case would be 2 by 1. And C21 would be 1 by 3. And C22 would be 1 by 1.
Thanks for watching. You can subscribe here if you want to get the latest from the Caribbean Scholar YouTube channel, or if you're ready, you can use the link in the description to hop onto our website and sign up for one of our premium courses.